A proton starts from rest, starting from rest, and accelerates across a potential difference of 200 volts between the two charged plates that are 20 centimeters apart. We first have to determine the maximum speed of the proton, then we're asked to find the current. Okay, so let's write out everything that we know so far. We know our delta V is equal to 200 volts. We know VI, and I'm going to use kind of a handwritten V for my speed because then it looks different than delta V, else I get mixed up, is 0 meters per second because it's starting from rest. My distance of the charged plates is 20 centimeters apart, which is 0.20 meters. We move it over 2 decimal places or divide by 100. And I'm looking for VF, is my question here. So when we're thinking about looking for our speed, we need to find the change in energy. Okay? So what we need to do to find our VF is we need to look for our delta E. Okay? Well, how do we find our delta E? Well, we can use this V and this D to find delta E and then apply it to our speeds. Okay, using our EK equals half mv squared. So the first step I'm going to do, number 1, is to go delta V is equal to delta E over Q. I'm going to rearrange to solve for my delta E.
I thought formula said that was the E with the arrow.
That what was, sorry?
That formula has E with the arrow.
Which formula?
The one you just put up there.
No? Delta V equals delta E over Q. Oh, yeah, no, I won't use D. I shouldn't have put that there. I'll use D. Thanks. I'll use this and my Q to find delta E. Thank you. And my delta and my D, what I'm going to use D for is to help find time needed for my current. Okay, we'll do that second. Yeah, thank you for pointing that out. Okay, so now we're back to here. So then our delta E, do you understand why I need to find delta E though? The change in energy? Okay, good, yeah. All right, so we have our 200 volts multiplied by 1.6 times 10 to the negative 19. Now remember, because this is a proton, and it's one positive of an elementary charge. An elementary charge on our data booklet is 1.6 times 10 to the negative 19. It doesn't mean that it's one electron charge, okay? Remember that it's elementary charge. So our delta E is 3.2 times 10 to the power of negative 17 joules. So now the second step I can do is I'm going to take my delta E and say that's my delta EK is my EKF minus EK initial. And I can make that assumption because it's starting from rest. So all of its kinetic energy that it would have gained had to have come from that potential energy. So your delta E is referencing your delta EK automatically. So since this starts from rest, this is a 0. My delta EK then equals EKF. I'm solving for VF, so VF is equal to the square root of 2 delta EK over M. Oops. And then you go to your data booklet to find the mass of a proton. Okay? So go find your mass of a proton. So your mass is 1.67 times 10 to the negative 27. So when you put this in your calculator, you should get 1.9576, etc., times 10 to the power of 5 meters per second. So to sig digs, 2.0 times 10 to the 5 meters per second. So that's the answer to A for this question. But then we're still asked about finding current. So this is B, finding current, okay? So to find current, I need I is equal to Q over T. Well, I know my charge of my proton, but I don't know time. But I know that this object accelerated, that the proton accelerated. So I'm going to use my distance in an acceleration formula of the information I know to find time. So we look at our acceleration formula, and we are looking for t is our question mark. D is 0.2 meters. Vi is 0, and we just found Vf. So we look for an acceleration formula that has all of those variables in it. Which one would that be? Yes. Vf plus Vi divided by 2 all times by t. So we are going to find t first using that. Then we can put the rest of that information into our current formula to find current. So D is equal then to, well actually I'm going to rearrange to solve for T. So rearrange to solve for T. And you can cross off Vi to make it easier for your rearrangement. So T will equal 2 times D divided by Vi. And for our VF, I'm not sure if we should use our SIGDIG answer or like our pre-SIGDIG answer for VF. I have a pre-SIGDIG answer because then it's more accurate. So let's use our pre-sig dig answer for our VF. I'll change that here too. So we should get 2.0432 times 10 to the negative 6 seconds. So now what we can do is we can use this in our I equals Q over T formula. Our charge is, we're just dealing with one proton, right, because that's our total charge. So I make sure I look at my question, it says just a proton. So I just need the one charge, 1.6 times 10 to the negative 19 coulombs, all divided by 2.0432 times 10 to the negative 6 seconds. Will give us 7.8305 times 10 to the negative 14 amps. So the sig digs, this is 7.8 times 10 to the negative 14 amps.